Hello guys, you're welcome back again to my YouTube channel. If you are someone that you are passionate about learning calculus, you have come to the right video. Don't forget, this is just actually the basics. So we'll be starting from the first part of calculus, which is called differentiation. Which is called what? Differentiation. So calculus has so many applications in any aspect, but we'll be starting from the basics. And before we understand differentiation, which is formerly known as dy dx and everything, lot of solvings, I would want us to learn what we call gradients. It is very important. It will help you to understand differentiation very well. So if you are wondering, this PDF is Engineering Maths by K.A. Stroud. So if you are looking for a PDF for reference to go and learn this thing more, just go on your internet, search for Engineering Maths by K.A. Stroud. This is the 7th edition, or rather I will be putting the link to my Google Drive so that you can click on it for the PDF. So now let's get to work. Don't forget, at the end of today's video, what you'll be able to do is you'll be able to determine the gradient of a straight line graph. Be able to determine the gradient of a straight line graph. Now, let's begin. Now, looking at this, gradients. I want to talk about the gradient of a straight line. Let's look at this diagram. For what is being written here, he said the gradient of the sloping straight line shown in the figure is defined as, jot it down in your note. I want you to jot this in your note. The gradient of the sloping straight line shown in the figure is defined as, jot this, the vertical distance the line rises or falls between 2 points P and Q all over the horizontal distance between P and Q. Jot that in your note now. Take a pen, take your jotting material and jot this down. It's a very important word. Now let's try to understand what they are saying here. Looking at this diagram, where P is a point to the left of point Q. Let's look at what they are saying. Where P is a point to the left of point Q. This is point Q, right? And this is point P. Now, this is just like I'm highlighting point Q to the right. Did you get? To the right hand side, right? And this is point Q to the left. Just like point Q going back to the left. And don't forget, as point Q is going back to the length, is to get to a point whereby that point and this point, they are in the same lane, right? So you can see that it's correct when they said where P is a point to the left of point Q. On a straight line AB, this is a point A and this is a point B, right? So a straight line AB, a point meet each other, which slopes downward from left to right. No, my bad. Which slopes upwards from left to right. From left to right. That means that this point P is sloping upward. Instead of this point P to go upward, it's going upward. What? From left. Now this is the left side, right? To right. So this position is in the left side, right? Is moving, is sloping upward. Instead of it to slope straight upward, it slopes from left to what? To right. Did you get? the changes in the x and y values of the points P and Q. Because for every point P and Q, for this point P has an x value here. Because this is what? X-axis. This is x-axis. So this is the value of x to this point, and this is the value of y to this point. So when they say the changes in x and y values of the points P and Q, so this is the y values of point P, and this is the x value of what? Of point P. And let's look at point Q also. Point Q, this is the x value of point Q, and this is the y value of point Q, right? They now said are denoted by the x and the y respectively. Full stop. So the gradient of this straight line is given as, don't forget, let's interpret this, right? Let's interpret this. The vertical distance the line rises or falls between 2 points P and Q. Let's look at this line. The vertical distance is going up, right? It's going up, right? It's going up, right? So as that thing is going up, it's changing in y value and also change in x value. But when this thing is going vertically, don't forget, as it's going vertically, it's in the y value, it's in the y axis, right? Y axis is vertical, y x axis is horizontal. So as this thing is going up, it's in the y value, right? That's why they say vertical distance the line rises or falls between point P and Q. This vertical distance, right? And don't forget, is what? Dy. Look at this now. The vertical distance. So this one is in the same lane with this, right? This line, the same lane with this line. So we call it dy. Abi, change the y value. Looking at this lane too. This lane from this point to this point, from this point to this point, right? So point x, right? Everything here is point x to down point x, right? So this one is going from here to here, and that is what x value. We could have chosen any pair of points on the straight line for P and Q, and by similar triangles this ratio would have worked out to the same value. Now please, if you don't understand this thing, if you still don't understand, don't forget this explanation is for those that have passion to study math, who really want to understand calculus for the basics. You may just, if you are someone that you just casually want to pass an exam, just want to get some things, you may not need to understand all this one I'm explaining for you on diagram. You may not need to. It's not really much crucial for you. Did you get? All you just need to know is that the gradient of a sloping straight line is what? Dy ds. Just jot that down. All you just need to know that what? The gradient of a straight line is what? Dy ds. That's just all you need to know. But for those that really want to be a passionate mathematician, that's the reason I'm explaining these diagrams. For them, its value is denoted by the symbol m. So therefore, m equals to dy over dx. So the gradient of a straight line is all denoted by what symbol m, and m equals to what? Dy over dx. So now, for example, if for some line, see the figure below. The figure is below. I will soon show you. P is the point 23 and Q is the point 64. Then P is to the left and below to the point Q. In this case, before we go into, let's be practical about these things. Let's look at this. Dy, don't forget dy is what? Change in y values, right? And ds is what? Change in x value. Just note that whenever they give you P as a point, this is point x and this is point y. You get? P is a point, this is what? Point x and this is point y. Did you get? In this Q, point Q, this is point what? x, and this is point y. So let me basically explain this. So the y is change in y values, right? Change in y values, right? So start from the second one. The y values of the second one is what? Of q is what? 4, abi? 4 minus, because when, if I have something here 1 and I have something here 2, if I say change in 1 to 2, means that it will be 2 minus 1. That means that the way 1 changes to 2, right, is 1. That means 1 plus 1 is 2, right? That's the meaning. Did you get? So that's the reason why the last one here has to come first. That's why it's 4 minus 3. Abi? That's equals to 1. And the x equals to the change in x value, right? The x value of the second one is 6 minus 2. So that m equals to the y dx equals to the change in, don't forget, that's the formula. Change the y values over change the x value, right? You have forgotten. The vertical distance, change dy over dx, right? So our dy here is what? 4 minus 3. 1. Abi? 4 minus 3 here is 1. That's what? Dy. Dx. 6 minus 2. 4. Abi? So that will be 1 all over 4. Right? That's equals to. You calculate it either using calculator. But if you're a mathematician, you should know the answer. 4 goes in 1. It's impossible. So you write 0. Point. Add your 0 to this one. 4 goes in 10. 2. Right? You remember 2. Add 0. 4 goes in 20. 5. Did you get? So now, this is just the diagram representation of the gradient we calculated. Right? So the gradient, that's the slope. The sloping rise vertically from left to right by 0.5 units for every 1 unit horizontally. If you have found any contradiction, please engage it in the comments. I want to believe that if you are coming to this channel, you are coming to learn. Did you get? And if you really understand what I've explained here, please and please like this video. It will really mean a lot to me. Comment and let me know what you have got. The what we have just displayed here, the graphical aspect, P of 0.23. This is x value, right? Don't forget the first one will be x value, right? That's 0.2, right? And 0.3, the y value. Did you get it? That's why so 3 here and 2 here, they meet at this point. Let's look at point Q also. Point Q, this is point what? 6, right? And this is what? 0.4. Abi? 6 x value, 4 y value. That's just a graphical representation. Yeah, looking forward to having you on board. I want to believe you have understand the first basics in calculus. Till we see another time, there is more to come. Prepare for this because you still have other things to learn, work examples on so many things. But take this for a take home. So that for the next time we are going to be meeting, and that is solve this in your personal closet. Solve this. Calculate the gradient of the straight line joining A, P of 1, 2, 3 and Q of 4,9. B, P of minus 2,6 and Q of 7, minus 5. C, P of 0, 0 and Q of 4,8. If you are someone that is you are not really much of a mathematician, and also use the formula, right? Don't forget. Let me just show you the guideline to number 1. 9 minus 3 all over 4. 9 minus 3 all over 4 minus 1. You get your answer. Right? Same thing also. Minus 5 minus 6 over 7 minus 2. It's just as easy. But as a mathematician, I'm looking forward to for you to solving it in a way that you draw your graph, you do it very well, just like the way we did it here. Just like the way we did it here. So please, till we see again next time, thank you all and bye.